Hello all, I am Mr. Lee, Chemsir. This video clip is to discuss with you all the answers in the test on the topic redox reactions and chemical cells. Let's discuss the questions one by one. Multiple choice questions first. Number 1, highest oxidation number. For nitrogen, it has many different oxidation numbers. In the compound NF3, make sure you know that F is the most electronegative element. So N has the oxidation number positive 3. In option B, H has the positive 1 as the oxidation number, therefore N should be negative 2. Option C, NaNH2, the oxidation number of N should be negative 3. Option D, HONH2, the oxidation number of N should be negative 1. So the highest being A. So the answer is A. Question number 2. Based on this reaction, you know that D is more reactive than E, right? Because D can displace E from a solution of the sulfate of E. So if we use these two metal strips, D and E, and put it in the lemon cell, then D is the more reactive metal, therefore electron will flow from D to E like this. And D is of course the negative electron, while E is of course the positive electron. And as electrons will get into electrode E, so reduction is going to take place over there. So E is the cathode, while D is the anode. So let's check the options one by one. Option A, electrons flow from E to D, of course incorrect. D2 plus ions are found in lemon juice. As metal D will lose electron after some time, so D will become D2 plus together with the electrons. So there will be D2 plus. So B is correct. Let's look at options C and D. Option C, E acts as the negative electrode, of course incorrect. D acts as the cathode, again incorrect. So the answer is B. Question number 3. Hydrogen-oxygen fuel cell. Incorrect. Okay, so let's check the options one by one. Option A is of course a correct statement. Okay, this is showing how the fuel cell works. Option B, water is formed in the cell reaction. This is of course a correct statement. Always bear in mind that the fuel cell works in such a principle, just like burning the fuel, hydrogen, combustion of hydrogen to give water only. This is of course the overall cell reaction. How about option C? Oxygen gas is passed to the anode. Oh, let's have a look. Oxygen becomes water. Oxidation number of O from 0 to negative 2. So this is a reduction. Oxygen undergoes reduction. Reduction should take place at the cathode. So anode here. So this is an incorrect statement. How about option D? Hydrogen gas acting as reducing agent. Hydrogen becoming water. Hydrogen, the oxidation number is 0. In H2O, it is positive 1. So this is an oxidation. And therefore, hydrogen H2 is acting as a reducing agent. So this is a correct statement. So bearing in mind that this question is asking you to find the incorrect statement, so the answer is C. Question number 4. From the information provided, as this is arranged in the order of the tendency of being reduced, mercury to iron has the highest tendency to be reduced. That means Hg2 plus is in fact the strongest oxidizing agent because it will undergo reduction like this to become the mercury. So the information provided is to tell you that Hg2 plus is the strongest oxidizing agent. Then if we just try to put all these 6 species just like the electrochemical series, then you can arrange it like this: Cu2 plus, and then H plus, and then Mg2 plus, Na plus, and finally Ba2 plus. So let's check the statements one by one. Option A. Ba does not react with H plus, so Ba should be here. H plus is here. So Ba is a actually the strongest reducing agent among the species involved here. So Ba should react with H plus. Strong against strong. So does not react. This is of course incorrect. Option B. Displacement reaction occurs when copper is immersed in MgSO4AQ. MgSO4AQ is here. Cu is here. So MgSO4 mixed with Cu. For such a combination, there should be no reaction, but the statement said reaction occurs. Therefore, incorrect statement. Incorrect. How about option C? Hg2 plus is the weakest oxidizing agent. Oh, that should be the strongest one. So incorrect. And then option D, Na has a stronger reducing power. Na, where's Na? Na is here. Then Hg, of course, this is a correct statement as Ba is the strongest, Na is the next one, okay? So this is a correct statement. So the answer is D. Page 2. For this equation, first of all, it involves an unfamiliar situation involving the Ce4 plus becoming the Ce3 plus. Anyway, to balance this half equation, it is very easy, okay? Just like this. How about the sulfur dioxide? This is more familiar to you. Sulfur dioxide becoming sulfate by the half equation method. You add 2H2O here, and then you add 4H plus here, and then 2 electrons here. Oh, from the two half equations, you notice that you need to multiply this by 2. Therefore, later on, Q here should be 2. So from the options, you can quickly determine that the answer is C. Question number 6. Here, first of all, you have to be able to identify that sulfur dioxide is a typical reducing agent. Therefore, if a color change will be observed, color change, the keyword is color change. Bromine, first of all, bromine is a typical oxidizing agent. Bromine will change from brown to colorless, therefore, it is correct. Let's take a look at option 3 first, okay? Similarly, acidified potassium permanganate is an oxidizing agent, so it will change from purple to colorless. Therefore, they will react and lead to a color change. How about option 2. This is a bit difficult. Fe2 plus is of course green, but when it is to be mixed with a reducing agent, if the reducing agent can reduce it, it becomes Fe. However, you need to know that this reduction from Fe2 plus to Fe is a bit difficult to occur because a strong reducing agent is needed. For example, a reactive metal like magnesium, zinc, and so on. For sulfur dioxide, it is not that strong to reduce Fe2 plus to Fe. Therefore, there should be no color change when they are mixed together. So the answer is B. Structured questions. Number 1, 1A is of course a redox reaction. You can find the oxidation number of S. It changes from positive 6 to negative 2. For iodine, the oxidation number changes from negative 1 to 0. So always remember you answer in such a sentence pattern. Part B, it is of course not a redox. Carbonate, oxidation number of C is of course positive 4. In carbon dioxide, also positive 4. For sulfuric acid, oxidation number of S is positive 6. Similarly, for sulfate, the oxidation number of sulfur is also positive 6. There is no change in oxidation number of all elements. I repeat, all elements. When I mark your scripts, I found that some of you mentioned something like this. There is no change in the oxidation number of carbon and sulfur. Therefore, it is not a redox. Of course, this is an incorrect idea because in a reaction that is not a redox, there should be no change in all elements, oxidation numbers of all elements. If you just confine your discussion to the fact that there is no change in oxidation numbers of C or S or C and S, actually the idea is not complete, and therefore you lose this 1 mark. Question number 2. Make sure you know that nitric acid, to write an ionic equation, rewrite NO3-, and then if it is concentrated nitric acid, the product is NO2. I'm sure you can write this overall equation using the half equation method, so I don't do it in details. NO2 gas, of course, brown gas. Page 3. Sodium hydroxide solution reacting with aqueous chlorine. Make sure you need to identify that co-dilute sodium hydroxide solution gives the hypochlorite ion. Okay, and it is different from hot concentrated sodium hydroxide solution. So make sure you memorize the products. The observation is actually trivial, so I don't discuss it further. Question number 3. This is a hydrogen oxygen fuel cell. Make sure you know that the electrolyte is concentrated potassium hydroxide, meaning that all reaction should take place in an alkaline medium. And bear in mind that the overall cell reaction is giving water. So if I were you, I will balance the half equation like this. No matter I am considering the cathode or the anode, because water is the final product. And then we can just use the half equation method, okay? So add H2O on the left and then add 2H plus on the right. But this is not the alkaline medium, so you have to add 2 hydroxide ions on both sides. So this part will become 2H2O, and this H2O will be cancelled with this, so leaving the correct half equation at nickel electrode X. How about nickel electrode Y? First of all, you add the 2 here, and then you add 4H plus on the left, together with 4 electrons. Again, this is not the alkaline medium, therefore you have to add 4 hydroxide ions on both sides. So 4H plus together with 4OH minus will give 4H2O. And then you do the cancellation, 2H2O, this 4 becoming 2. So you get this half equation. Explain why fuel cell is environmentally friendly. Make sure you need to write only water is produced, and it is always better to mention that water is non-polluting. Question number 4. I think I will focus on the discussion of part A. Make sure you know how to answer question of this type. Whether the electrode is cathode or anode, you need to answer the question, explain it in terms of something like this. Reduction takes place, or the species gain electron. Okay. However, when I mark your papers, I found some of you put down wrong ideas by saying that it is because Y undergoes reduction, or Y gains electrons. All these are incorrect ideas. Or even just mention it gains electrons, or it undergoes reduction. Please note that if you use it here, it refers to the graphite electrode Y. And actually, the graphite electrode Y, it is graphite, okay? Graphite, it is an inert electrode. It is not going to take part in the cell reaction. Therefore, if you write ideas like this, make sure you know that these are wrong ideas, even though you mention reduction or something that gains electrons. So be careful next time if you make mistakes this time. These two are so trivial, I don't discuss it. And for the half equation involving the change from dichromate to chromium-free, make sure you put the 2 here and remember that there are 6 electrons. For the last part, overall equation, again, I'm not going to demonstrate to you here because I have been doing this many times in my lessons. So your own practice, I'm sure you can do it. Thank you for watching my video. Enjoy your Christmas days.